Kia ora, my name's Vin. I just quickly wanted to show a tool that I've been working on recently called FalseLight. So what is this? It is an AVL style lighting system that doesn't use real lights at all. Instead, these utilize volumes that you can place within your scene, and they kind of project lights onto the surface of your 3D environment like decals. So just to begin, this one here is an additive style light. So it's using the normal map screen grab to create shadows and normal imperfections. Yeah. And then next we have a post-contrast style light. So you can see there's a little bit more detail in this compared to the additive light. And that's because it also captures unlit color before it is processed. And so that color is pushed through into the light and you get a little bit more contrast there. One of the settings that we have available for these lights is posterization, so you can get stylized rendering effects out of it. The lights are built modularly, so one of the modules is a flicker module. You also have the ability to punch gradients into the light volume as well. So this is a simple vertical gradient, and this one's using a radial gradient, though it's hard to see because of the flicker. And you can also extract the gradient from a texture, either sampling the texture on its vertical or horizontal axis, and then that will output as a radial texture ramp. Now on top of that, this entire room is sitting inside an area light that has a gradient attached to it. So nothing in this scene is lit, nothing in this scene is baked. This is all being processed through the false lights. And this interior room light is starting with a kind of brown orange and then moving up to white to create that gradation effect. Yeah. Now, some of the funkier things you can do with the modular elements within the light system is there are 3 levels of triplanially mapped noise within it that can either be output as a single noise layer or a multi-noise layer where you have shifting layers interacting with one another. Similar technique that you'd usually see with like cloud shadows or something along those lines. But from those noise outputs, you can map them internally in the shader to a lot of different spaces. This one is being mapped to the gradient, and then the noise itself is being used as the gradient ramp. So yeah, you can get some pretty cool stylized effects out of it. Next one we'll go over to is this room, which always gives me vertigo. So what's going on here is this is a single triplanar layer. So we've just got one repeated tiling moving texture that's projected triplanarly through the light volume. And obviously that's been lit green. But what we can also see here is between this room and that room, you start seeing pixelation, and that's being caused by an in-screen effect as well. The shader can process and push out the light into screen space and then pixelate it within the screen space. So you can easily move from unpixelated to fun little pixelated spaces and light volumes. It's a cool little effect. And additionally, on top of this one, it might be hard to see with compression, video compression, but this effect also has dithering included in it as well. So using these kinds of shaders, or these kinds of lights, sorry, you could have a completely unlit environment with no pixelation in the base shaders or pixelated effect on the environment shaders. Introduce this light into it and it'll automatically bump it up to something that's a little bit more retro in its vibe. Yeah. Then moving into something more basic, this is just a simple spherical light. The light exists in the center of the sphere, and part of the reason why I've done that is to show just how the volumes interact with geometry. So because we don't have any, we're not creating any shadows. I haven't figured out or solved how to create realistic shadows with the system yet. We are instead just evenly applying the light throughout the spherical volume. I have put a little bit of noise into the shape of the light. So the fall off of the light or the intensity of the light can be shaped by noise, so you can get additional unique patterns in there. And in this case, that noise is exactly the same height map that's used on this texture. Now if I jump across to the other room, I'm doing something very simple here, except I'm also using the gradient within the light cast, or the light volume. So you'll be able to see that it goes from this kind of nice peachy color to a blue as it rolls off, and that's because the gradient is being modulated by the height map from the rock texture on the sphere that's been input into the light volume. Yeah, and final one is, this is a cone light, so you can also do spotlights in this. So you can use this setup if you want to for like a lamp light or a handheld torch or something. Obviously you're not going to get any shadows produced, but you can use these spotlights to get interesting highlight effects if you so wish to. So without doing any additional surface shader tricks to get a nice moving kind of golden glowing effect on this sphere surface, I'm just using one of these lights and projecting it against the sphere itself. So if I was to toggle it off, all you'd see is this, which is pretty cool. So yeah, that's kind of where I'm at with these at the moment. I'm just going to jump out of play mode and show you a little bit about the system itself. So as you can see, we have all of the different spaces that I just moved through. And even in the scene view, you get that pixelated render effect, though it's a little bit more downscaled in the scene view, which may make things a bit more difficult to see, but hey, that's life. And then everything else that we saw there. So I'll just first jump into the come on, give me the selection I want. Into that cone light. There it is. So like I said, it's just a simple cone light. It's supplied with handles in the editor to be able to make it a bit more expansive. You have an amount of fall off there that can be applied to it. Distance. Then across in the shader we have additional fall off. Where is it? Oh yeah. Range boundary softness. So that's just going to create an additional blend as it moves across. Let's focus on this light quickly. Which one are you? There we go. So if I jump into the shader, there is that little bit of linearity, or that radial gradient there, sorry. So it's as simple as, let's change up the gradient for red and then blue, and now we've got, as if sphere emanates outwards, a movement towards more of a bluer tone. Then you could imagine if you're doing something with like pastel shading, you might find a nice coloration around there, and maybe like I want a little bit more saturation. Can kind of get something that's, you know, kind of pastel. You've got that normal responsiveness, so how much the light responds to the surface normals. You can push it all the way up and do some weird stylized things. It kind of breaks the effect, but you never know. Depending on what you're making, this might be exactly what you're after. Not really going to see the softness pump through there, or the shading wrap too much. The shading wrap just means that you get a little bit more wrap around in that normal response. So you could turn just a regular texture into something a little bit more odd, let's say. Let's check FalseLight on this one too. So, you know, you can push it through and make it a little bit more grungy pretty easily. Because it's screen space, it will retain the pixel level even as you move back, but it should kind of clear up and become more detailed as you get closer. What else do we have here? I'll just move those back to where they were sitting originally. Is that pixel layer still on? Yeah, it is. Cool. So now that's off. So you can see here there is the noise projection as well, so I can turn that on so it's moving. There we go. Something that I really dislike about world space noise is that when you have like multiple lights and you move them around, there's like this continuity that happens. Each light doesn't feel unique to the next. So I've pushed in some world space randomization that is unique to the light. Which, I don't know, I think it's pretty cool. Don't know if it is cool to you or not, but this just allows for a offset of noises, so each noise can be tuned to be independent, completely independent from the light source next to it. Yet again, this can create nice, you know, stylized effects on surfaces when it's being used. Let's just grab that sphere. Which one is this sphere? There we go. So as you can see, as the sphere moves about, you get that that fall off with the volume. I really do want to try and implement ray marched volumetrics into this, but at the moment it's looking to be a little bit too compute heavy, so I'm just going to leave it at this. And I'll grab that sphere and bring it across to the pixelated space, so straight away you can see that the sphere is also interacting with the this area light. The base system that these lights run off is still scaffolded to a point within the local space of the volume. So it means that you can experience light dropping and unexpected kind of light culling as you get close to the center of a volumetric space, but or one of these area lights. But that is usually rectified, if I can get the right area, by tuning your normal response. So let's grab that sphere again. I'll bring it to where it was, where it wasn't really getting any of that central light response. And then back to the area light. And there we go. If I bring the normal response down, let's say just to a standard 1, you'll still be getting light pass through. You can also do a surface wrap. So like I said, that kind of like spills over normals in a way, normal detection. So that might also bump up the intensity of the light source in a way that allows the objects at the central point to be read more clearly in the shader. Then let's bring it across to here. So in this space, the area is really only at the bottom of the environment. So I can bring it up and move it about. And like I said, because it's like a decal projection, it will cover every surface it hits within that environment or within its volume. What I can also do there is dial up the softness a bit. So a lot of the core shaping elements interact with one another, especially when you're using noise. So you might have to move through the shader and tweak a couple of things to get the right effect. All right. And because this is an AVL style lighting system, it uses these massive chunks of geometry. This is all of the light geometry that you can see here, and it's pushed way out to the distance. Part of the reason why it's scaled so far is because there is a moment when you're outside the geometry and then you move into the geometry where you get light darkening. Now I've done all these different things to try and solve it. Well, look, there you go. You can just see a slight, there we go. You've got outside the geometry and inside the geometry. Anyway, talking about the light darkening, it's because you're moving between the threshold of, or you're right on the edge of the hull, in this case, the geometry hull, and there's a slight render step that's taken when you transition from outside to inside. That means you just get this artifact that appears, and it's just a little intensity reduction. So when working with this kind of setup, my main principle would be try and place lights intentionally so that you don't get these little light pops as you move into the hull geometry. And that can be done by just making sure that your hull is the right size. So I've got controls for that. Let's turn these back on. I'll take this area hull and I'll just adjust its multiplier. So the scale just rescales the hull comparative to the volume's actual size. So yeah, pretty much if I was doing, in reality, if I was doing something like building this dungeon, I could very easily just put the hull at that size. And because I've got a wall here, that light pop is not going to be seen in the game. Whereas if I didn't have the wall, just around about here as you're halfway up the stairs, you get a light pop. You get that little hull entry transition happening. So yeah, this is pretty much what I wanted to show off for now. I've gone to the extremes with this, obviously, but you can use it for more subdued, sensible lighting as well. What I plan to use it mainly for is to try and get like slight painterly effects on surfaces. Depending on the size of your scene, you will need to watch out for overdraw. So you can put a good number of these lights into your scene. I've tested up to, I think it was 200 lights, and once we got to about 100, started to see significant frame rate reductions, got to 200 lights, and I was running at about 15 frames per second. So, you know, use sparingly. You can also use these in conjunction with the regular Unity light system. There's also a false lighting AVL style lighting pack on the Unity store by Lazy Etsy, I think it is, called Fake Point Lights, and that uses an even cheaper variation of this little trick. I would definitely recommend going and checking out that asset. It is paid, but it is very cool, and it will save you a lot of time. Oh, sorry. One last thing that I've got to talk about was masking. So the fake point lights, or the fake lights that I was talking about by Lazy Etsy, are just spherical lights and spotlights, and I've used them in a lot of little projects, but the one downfall I found with them is that because there's no shadow cast and because they have these fixed volumetric sizes, you can get like overflow between spaces that you may not want. If you're building a sector-based level where you've got like corridors and small rooms, and you want to switch out regular lighting for just simple non-shadowed stylistic lighting like this to fill in your spaces, you would get overflow between rooms, and you wouldn't be able to properly specify the dimensions or the boundaries of corridors or hard geometrically shaped areas. So that's why I made the area lights, the box lights, and then that in conjunction with box masks. I also have sphere masks in there as well. I can cut the effect of the light wherever I want, which I think is really cool, and it really does help artistically just kind of define the regions of your environment a bit better. You could, if you wanted to be really hacky, you could, you know, use masks instead to like make your shadowing. I don't know if that's really what you want to do, but let's pull up a sphere mask, and I'm gonna bump that radius out. So cool. So there we go, and I'm just gonna make a fake soft shadow. Now you probably notice this goes all the way to black, and that is, as I said, there is no lighting in this scene whatsoever. Even the environmental light is toggled down to 0. If I turn it up, then you start getting a different effect in the scene. It's cool, it's fine. These lights can adjust, can be adjusted to better represent in a fully lit scene like this, or a scene with more intentional lighting. So I'm going to target something called post-contrast intensity. You know, it's not the best, but it works. And it's really just about what you're wanting to get out of your lighting, you know. So there we go. We have something else going on there. Realistically, you're not going to have a full white light, so you might have something a little bit more like this. And I can dial down that intensity a bit more to something that's just got a nice neon atmospheric look to it. What I do hope to do in the future as well is potentially turn these light casts or make a light cast variation that will allow you to cast a sprite onto a wall, or radially diffuse a sprite through the volumetric space. So you could do like neon lights, just built in a emissive texture that's supposed to represent a neon light, and then utilize the texture in this to project a light volumetrically and disperse it into your environment. So yet again, you've got another little hacky trick there that could potentially be used, but this is all stuff in the future. Anyway, kia ora again. Thanks so much for having a watch, and have a good rest of your day.